You know, there is this one image in our stack of sources today that it completely stopped me dead.
Oh, the visual production script.
Yeah, exactly. It describes this incredibly cinematic, just highly contrasting scene. So in the foreground, you have this translucent human brain, right? Rendered in glass. And it is pulsing with this cool, pristine blue neural light, just perfectly ordered.
Right, very sterile, very clean.
Exactly. But then in the background, literally bleeding through the walls of the sterile laboratory, there are these violent cracks of amber red fire, just casting chaotic shadows everywhere.
It is a really striking visual, and honestly, I think it perfectly encapsulates the deep dive we are taking today. Because, well, today is March 30, 2026, and we are sitting right in the middle of what has to be the ultimate historical irony.
It really is. I mean, we are watching scientists literally decode the fundamental biological mechanisms of how humans think, and they're doing it at the exact moment that human decision-making on the world stage looks, well, completely irrational.
Absolutely, yeah.
So, because of that, we are skipping the usual market summaries today. No tickers, no oil prices, no charts.
Thank goodness.
Right. We've hammered that enough this week. Instead, we are focusing on this collision. The collision between the chaotic reality of the macro world right now and the pristine, emerging architecture of the mapped human mind. And crucially, we're going to explore what this means for the AI architectures you will be relying on tomorrow.
Right, but to really understand the weight of this technological leap, we kind of had to look briefly at that red fire in the background, because the geopolitical reality today is intense.
Yeah, it's unavoidable.
The conflict in the Middle East has escalated sharply. We're seeing reports of Iran launching heavy direct retaliatory strikes on Israel.
And, I mean, the details on the ground in the digest are stark. We are looking at the destruction of a $700 million U.S. surveillance aircraft.
Yeah, that was a major flashpoint.
And the UN Secretary General just issued a very severe warning. They're saying this exchange has pushed the conflict toward an uncontrollable spiral.
Which is especially devastating, given that this is all unfolding right during Eid and Nowruz celebrations. It's just a deeply volatile moment.
It is. And actually, we need to pause here for a second just to be crystal clear with you, the listener.
Yes, absolutely.
We are looking at these events purely through the lens of the data on our desks. It's just to provide the necessary context for today's theme.
Right. We are absolutely not taking any political sides here.
None at all.
Nor are we endorsing any viewpoints regarding the conflict itself. We are simply reporting the reality of the world as it stands this morning based on the Intel digests.
Right. Our role is just to lay out the facts of the source material. But it is that exact contrast that we really want unpacked today. Think about that visual again.
The amber red fire?
Yeah, the fire of the real world against that cool blue neural light of the laboratory. It raises this fascinating question. Why is it that our technology is achieving this crystal clear, absolute precision while our macro geopolitics feels like it's just descended into total static?
It's the defining paradox of the moment, I think. And in a strange way, the complete failure of human decision-making on the macro scale is exactly why today's biggest technological breakthrough is so compelling.
Because we're looking inward.
Exactly. Because while the outside world feels entirely unmappable right now, on the micro level, the actual biological machinery of how you and I process information we have just mapped the unmappable.
Okay, let's dive into the blue light then. Let's talk about Meta's Tribe V2.
Oh, this is huge.
It's massive. This is a new foundation model that was released just a few days ago, and its entire purpose is to map human brain responses at scale.
And I mean, the scale of what they have done here is staggering. They trained this model on over 500 hours of fMRI data.
Wow.
Yeah, pulling from more than 700 individual participants. The ultimate goal of Tribe V2 is to predict exactly how a human brain will light up in response to specific visual and auditory stimuli.
Okay, wait, before we get too deep into the AI side of this, let's make sure we are grounded in the biology. Because when we say they trained it on fMRI data, what is that actually measuring?
That's a great question.
Because we know it's a brain scan, but what is the literal mechanism being recorded there? Is it electricity?
No, actually it's not. So fMRI stands for Functional Magnetic Resonance Imaging. It doesn't measure electrical impulses directly. What it measures is blood flow.
Oh, okay, just purely blood flow.
Right. So when a specific region of your brain becomes active, say, your visual cortex, when you look at a photograph, those neurons fire, and suddenly they need more oxygen to replenish themselves.
Makes sense.
So the fMRI detects that highly oxygenated blood rushing to that specific tiny millimeter of your brain.
Got it. So Meta effectively gathered 500 hours of 3D heat maps, showing exactly where the blood rushes when 700 different people look at pictures or listen to sounds.
Exactly. And there's this infographic in the data illustrating the result, which is just brilliant. It shows that glass brain again. And on one side, you have these cascading panels of photographs, colors, audio waveforms streaming in.
Like a data feed.
Yeah. And on the other side, dense columns of predicted brain activation data are pouring out. It's predicting where that blood flow will happen before it even happens.
And here is where we get to the real breakthrough, because the most crucial detail about Tribe V2 is a capability they're calling zero-shot cross-subject prediction.
Yes. This is the holy grail of neuroscience right here.
Okay, but let's unpack that jargon for everyone. What does zero-shot actually mean mechanically in this context?
Okay, think about it like learning to drive a car, right?
Yeah.
If you spend months learning to drive, say, a Honda Civic, you understand the physics of driving, steering, braking, accelerating.
Right, the fundamentals.
Yeah. So if someone suddenly dropped you into a Ford Mustang, you don't need to relearn how driving works from scratch. You just drive it.
You just adjust a little and go.
Exactly. That is zero shot. The AI has learned the fundamental physics of the human brain so well that it can look at a completely new person, an unseen subject, and accurately predict their neural response to a totally new task or language.
Without ever scanning them first.
Without ever needing to be fine-tuned or trained on that specific person's brain first.
See, I have to push back on this a little bit, though, because a brain isn't a standardized car engine.
Sure.
My brain is uniquely wired by my memories, my childhood, my specific experiences. How can an AI achieve zero-shot prediction on my brain just by studying 700 strangers?
That's a fair point.
I mean, is it suggesting there's some sort of universal visual code for humanity?
It is suggesting exactly that.
Wait, really?
Yes, and this is the profound shift we're seeing. It is finding the foundational patterns of human cognition. Because yes, your higher order associative memories are entirely unique to you. How you personally feel about a specific song is unique.
Right, like if a song reminds me of a bad breakup or something.
Exactly. But the baseline biological architecture of how your auditory cortex physically processes the frequencies of that song, or how your visual cortex detects the edges of a shape, that shares a universal structural code across all humans.
Oh, wow.
Yeah. By analyzing those 500 hours of blood flow, Tribe B2 isolated the signal from the noise of our individuality. It essentially found the baseline operating system of human perception.
That is wild. It really is like they crowdsourced the architecture of human thought.
They did. The visual in the script even shows this faint grid of 700 tiny silhouetted figures standing behind the brain, and each one is emitting a single soft dot of light that feeds into the model.
And Meta has made this an open source release too.
Which is huge.
Yeah.
That is going to completely upend both cognitive and clinical research. We are moving neuroscience from this bespoke, patient-by-patient observational field into a truly predictive, scalable science.
Because we're finally defining the architecture of thought. So, okay, we have mapped the biological brain. But the really fascinating part of all this for you, the listener, is how quickly this biological mapping is mirroring what is happening right now in the artificial intelligence landscape.
Yes, the parallels are undeniable.
Let's look at the broader picture for a second. The first quarter of 2026 just closed, and we hit a ridiculous record. 255 distinct model releases in 3 months.
It's been an absolute flood.
OpenAI's GPT 5.4 just launched and is currently holding the intelligence index lead at 57.17. Minimax is sitting in second, and Alibaba has shipped, 8 different variants of Qwen 3.5?
Something like that, yeah. It's primarily been open weight models flooding the zone.
Okay, let's do a quick ELI 5 on that for a second. When we talk about foundation models and open weight and parameters in this context, what are we actually building here, just to ground the analogy?
Sure. So a foundation model is essentially a massive general-purpose AI trained on a vast amount of unstructured data. It is the raw engine. When we talk about parameters, think of them as the digital equivalent of synapses in your brain. They are the billions, or sometimes trillions, of tiny connections and weightings that determine how the model decides which word comes next.
Okay, and open weight.
An open weight model means the creators aren't just letting you use the final product through some lockdown web interface. They're giving you the actual underlying mathematical weights.
So they're handing over the recipe.
They're giving you the baked cake and the exact molecular structure of how it was baked, which allows developers to run it locally and modify it however they want.
Got it. So we have 255 of these massive digital brains out in the wild just from Q1. But looking at the data, the raw intelligence race, just piling on more and more billions of parameters to see who gets the highest benchmark score, it's actually hitting a quiet stretch.
It is. The sheer brute force approach is plateauing.
Why is that?
Because piling more and more digital synapses into a single, massive, monolithic model is creating diminishing returns. They hallucinate, they lose track of instructions in long context windows, and frankly, they are incredibly expensive to run.
Right.
The real story now isn't just about raw model capability, it is about how we build them, how we architect them.
And here is where I think the most important connection of the day happens. We spent all of Q1 essentially building raw brain tissue. All 255 of those distinct models are like massive clumps of unspecialized digital neurons.
Yes.
But a giant clump of neurons isn't a functioning brain.
No, it's not.
No, just like Meta is mapping the specialized distinct regions of the human biological brain with Tribe V2, AI labs are trying to figure out how to wire these raw capabilities together into specialized functioning lobes.
That is a phenomenal analogy.
Yeah.
That is exactly what's happening. And that move from raw tissue to specialized lobes is exactly what the industry calls agentic frameworks.
Agentic frameworks, okay.
Yeah, we are moving away from these monolithic models that try to be the entire brain all at once, and we're moving toward orchestrated systems of highly specialized agents.
Let's break down how that actually functions mechanically, because there is a new release from ByteDance in our sources called Deerflow 2.0 that illustrates this perfectly, right?
Oh, absolutely. It's an open source framework specifically for running isolated AI agents for discrete tasks.
Walk us through the structure of it.
The structural blueprint for Deerflow 2.0 is just beautiful in its logic. Imagine a digital environment with a central hexagonal orchestration hub.
Okay, picture a hexagon in the middle.
Right. Radiating outward from that hub are 6 distinct capsule-shaped agent pods. Each pod is isolated in its own sandboxed environment, and each one handles one highly specialized task.
Okay, so walk us through the actual data passing here. If I give Deerflow 2.0 a complex prompt, how do these digital lobes communicate with each other?
Let's say you ask the system to research a competitor's financial history and write a summary report.
Okay, pretty standard task.
In the old monolithic model, one giant AI tries to hold the entire internet search, the math, and the writing all in its head at the exact same time, which is why it drops the ball and makes mistakes.
Right, it gets confused.
But in Deerflow, the central hub receives your request. It immediately activates the search agent pod. Now, that agent's only job in the entire world is to browse the web and pull raw data.
It doesn't know how to do anything else.
Exactly. It does its search and hands the raw text back to the hub. The hub then routes that text over to the data analysis pod, which only does math.
So it's crunching the financials.
Right. It crunches the numbers, sends the pristine data back to the hub, and finally, the hub sends that to the synthesis pod, which writes the final report.
So they are completely walled off from each other.
Completely sandboxed.
The writer agent doesn't need to know how to search the web, and the math agent doesn't need to know how to format a paragraph.
Exactly.
It is literally a digital visual cortex talking to a digital language center.
Precisely. And the beauty of this is resilience. If the code agent writes a script that fails, it is trapped in that sandboxed containment field. It can't crash the whole system.
Oh, that's smart.
The central hub just looks at the error, resets that specific pod, and tells it to try again. It is modular, resilient architecture, mimicking biology.
And for you listening, this isn't just theoretical computer science. This biological architecture is directly changing the software you're going to be using every single day.
It's happening right now.
Yeah, there's an AI agent mentioned in our stack called Manus, and this thing is designed to replace your entire traditional tool stack.
Manus is incredible. It's the realization of the end-to-end autonomous workflow. The visual they use to describe it in the digest is really fascinating, actually. It's a single luminous orb that is absorbing a dozen different dissolving tools.
Right.
You see a magnifying glass for search, a spreadsheet for data, a pen for writing, all melting into this one unified agentic system.
Right, because right now, your daily workflow probably involves juggling 10 different web tabs and 4 different applications. But Manus introduces Single prompt execution.
Yes.
Instead of you prompting an AI step by step, like asking it to search, then pasting that search into another prompt, then asking it to rewrite, you just give Manus the final destination.
You just give it the goal.
Yeah, you say, build me a dossier on this topic.
Right.
And it spins up its own internal Deerflow-style agents. It orchestrates the research, cross-checks its own work, and just hands you a finished product.
And you can see this agentic shift happening across the board right now, not just with Manus. Look at tools like Cursor from the Digest.
Oh yeah, the coding environment.
Right, it's an AI-enhanced code editing environment. But it doesn't just act as a glorified autocomplete anymore.
Right.
It uses specialized agents in the background to read your entire code base, understand the context, and actually scaffold complex logic autonomously, which is resulting in massive measurable speed gains for developers.
And then there is Lovable, which the name sounds funny, but it sounds like magic until you understand the agentic framework beneath it.
Yeah, vibe coding.
Yes, vibe coding. The documentation says it lets you vibe code a web app from plain language.
It's a hilarious term, but it works.
It really does. Like, if you need an internal dashboard, you just describe it. I want a dashboard that looks like this and tracks this. But mechanically, under the hood, what is actually happening is a rapid-fire handoff between those specialized agents we talked about.
Exactly.
One agent drafts the HTML structure. It passes that to a styling agent that writes the CSS, which passes it to a testing agent that looks for bugs. They are doing all that internal routing in seconds.
So all you see on your end is a finished app just appearing before your eyes. No developer required.
Unbelievable.
And it extends to regular daily web browsing too. Tools like Comet Browser now offer a free agentic mode. So it isn't just a search bar anymore. It is an autonomous system that navigates websites, fills out multi-page forms, and extracts data entirely on your behalf.
So, if we synthesize all of this, the core takeaway for you today is that we are officially moving out of the era of prompting AI. You are no longer the central hub micromanaging every single step of the process.
No, those days are ending.
We're entering the era of delegating to autonomous modular systems. Systems that orchestrate complex tasks exactly like the specialized regions of a newly mapped human brain.
It really is a profound transition in our relationship with technology. The software is shifting from being a static tool that you wield to an active agent that you manage.
Absolutely. Let's bring this all together. We started today looking at a geopolitical landscape that feels completely chaotic, violent, and unmappable.
The amber red fire.
Yeah. And we contrasted that chaos with Meta's Tribe V2, a stunning breakthrough proving we can finally map the universal foundational code of human cognition at the micro level. Zero shot predicting how our minds physically react to the world.
Which is just an incredible milestone.
Yeah. And then we explored how that exact biological modularity is now serving as the architectural blueprint for the next generation of AI, with agentic frameworks like Deerflow 2.0 and Manus wiring raw digital tissue into specialized functioning lobes.
It really is the ultimate collision between the messy, unpredictable reality of humanity and the pristine, logical systems we are building. Which actually brings us to one final, slightly unsettling thought to leave you with today.
Oh boy.
Lay it on us.
Well, think about it. If the next generation of artificial intelligence, these autonomous, self-directing agents that will soon be running our workflows, our code bases, and our research, if they're being fundamentally architected on the neural mapping of the human mind,
Yeah.
what happens if these systems eventually inherit the exact same human irrationality that is currently setting the macro world stage on fire?
Wow. Okay. That is a heavy one to sit with. If we build them in our exact image, modeling their digital lobes after our biological ones, do we inevitably get our flaws along with our brilliance?
It's the big question. Definitely something for you to think about the next time you delegate a task to your AI. Thank you for joining us on this deep dive. Keep questioning the world around you, and we'll see you next time.